NASA just saw something in the latest 3I Atlas data today, and it confirms what a lot of people were quietly afraid of. This thing isn't just changing, it's evolving fast. Every time we think this interstellar comet has picked a mode and is going to stick with it, the next set of images shows a new version of the object. If you've been following this story and you don't want to miss the moment this thing either stabilizes or does something we've never seen before, make sure you're subscribed, drop a like, and stay with me till the end. Because what showed up in today's observations makes it very clear. 3I Atlas is not done transforming. Here's what NASA just saw. Before we continue, if this has your attention, you can subscribe, turn on notifications, and hit like anytime. And for the best viewing, switch to full screen and enjoy what's coming next. Today's update was built around one idea. Compare everything. Yesterday versus today. Old models versus new data. Different wavelengths stacked on top of each other. The first surprise came from a set of coordinated images taken only hours apart by different observatories. In the older frame, the inner coma, that bright tight glow around the nucleus, had a stretched bar-like shape with two faint tail branches fanning out behind it. In today's frame, that same region doesn't just look sharper, it looks more organized. The inner coma has developed a clear, twisted structure, a spiral-like pattern curling outward from the center. It's faint, but once you enhance the contrast and subtract the background, you can literally trace the spiral arm wrapping around one side of the nucleus and feeding into the main tail. Side by side, it looks like 3I Atlas went from messy chaos to complex pattern in less than a day. That's the first clue that it's evolving, not just flickering randomly. The second clue comes from the light curve. Yesterday's brightness pattern per rotation was already strange. Uneven peaks, slight drifts in timing, hints that the spin state wasn't perfectly stable. Today's photometry shows a new feature. On top of the main rise and fall, there's now a repeating secondary bump, a smaller pulse of brightness that appears at a consistent phase in each cycle. It's like a heartbeat inside a heartbeat. That usually means one thing. A new active region has come online and is now contributing regularly as the comet spins. So in just one day, the coma went from a stretched blob to a visible spiral, and the rotation signature went from kind of weird to clearly multilayered. Now add the third piece, the spectra. When NASA's teams compared yesterday's gas fingerprints with today's, they found a subtle but important shift. The overall activity level hasn't exploded, but the balance between different volatiles and dust has tilted again. Lines associated with deeper, more stubborn ices are slightly stronger. Scattering signatures from larger dust grains have grown. Meanwhile, some of the lighter components that dominated earlier in the encounter have started to fade. That tells you exactly what's happening physically. 3ASE Atlas is beginning to vent from deeper layers than before. The outer stuff, the easy ices, the loosely bound dust, is being stripped away, and now the interior is waking up. The evolving spiral structure, the new rotational pulse, the shifting gas mix, they're all saying the same thing. This comet isn't just getting dimmer and drifting off, it's changing state. Inside, the heat that it absorbed near the sun is still moving inward, reaching fresh pockets of material that have literally never been exposed to a star like this. Each time one of those pockets crosses its critical temperature, it opens a new vent, feeds a new jet, or reshapes the existing flow. From the outside, that looks like a new spiral in the dust. A new bump in the light curve, a new mixture of gas in the coma. And because the vents aren't all pointing in the same direction, every new one that turns on changes the forces on the nucleus too. That's where today's non-gravitational update comes in. When they fed the newest position data into the orbit solver, the extra push from outgassing, that tiny engine effect, didn't vanish. It actually became more consistent. For the first time in a while, the magnitude of that push stopped jumping and started lining up with what you'd expect from a stable set of jets. But the catch is this: those jets weren't there toward a new configuration. It started as a chaotic, flaring mess. Now it's starting to act like a more coherent multi-jet engine, powered by deeper layers and more organized flows. And that's both fascinating and dangerous, because if the jets keep stabilizing while the spin state is still shifting, you end up with sustained directional torque on a nucleus that's already been stressed and cracked by months of violent heating and cooling. Think about spinning a fragile object faster and faster while also drilling deeper holes through it. At first you just reveal structure, then you reach a point where the structure can't keep up. That's the line 3I Atlas seems to be walking right now. On one side, it finishes this evolution, settles into a new, stable pattern, and escapes our solar system as a scarred but intact interstellar comet. On the other side, each new layer that activates adds more stress than the last, and the object crosses a threshold where it can't redistribute that stress anymore. At that point, evolving fast turns into breaking apart. We're not there yet. NASA's language today is still clinical. Evolving coma morphology. Changing volatile composition. Refined non-gravitational parameters. But hidden in that careful wording is a simple truth. This object is not cooling off. It's progressing. Layer by layer. Jet by jet. Day by day. If tomorrow's data shows the same spiral, the same extra pulse in the light curve, and a stable push in the same direction, we'll know 3I Atlas has locked into its new mode. At least for now, if tomorrow's data shows yet another twist, a new pattern, a new direction, new structural change, then today's evolving fast is just one frame in an even faster transformation. Either way, we're not watching a static visitor. We're watching an interstellar object rewrite itself in real time as it leaves. So if you want to see whether 3I Atlas finishes this evolution quietly, or takes it one step too far, make sure you're subscribed. Because whatever NASA just saw today is clear. 3I Atlas isn't done changing. It's evolving, and it's doing it fast.